This is Algebra with Finance A, Unit 1, Lesson 6 on linear graphs. Really, this lesson is about practical applications of linear functions or linear graphs to real-world situations. And so really what we're about is recognizing when we have a linear situation. A linear situation occurs when we have a given start value. Here, let me change the color. Start value. So we have some start value. Okay, and some rate of change. The start value we'll call v, and the rate of change we'll call m, because those are the parts of the linear equation y equals mx plus b, or you'll sometimes see it y equals a plus bx. But in this course, we're going to deal with it in the form y equals mx plus b. M is something called the rate of change, of course, but in graphs, it's called the slope. V is the start value, true, but it's also the y-intercept. Okay, so we can formulate word problems like this all day long that fit this situation. So, for example, Wally has stacked 470 bricks. Bricks. Okay, right? So that obviously is our start value. He's already got so many bricks stacked. He can stack 27 bricks a minute. Actually, let's make it smaller than that. He can stack 8 bricks a minute. Can't seem to spell bricks. Bricks a minute. Okay, and that obviously is our rate, right? So we've got this situation. He's already stacked 470 bricks. He can stack 8 bricks a minute. The hint that that's a rate is a minute. Bricks per minute or a minute. Anytime you have a rate, it's 2 units, like miles per hour, feet per second, dollars per hour, etc. So we have one rate of change that is changing over another, right? So he can stack 8 bricks a minute. So there is my V, and there is my A, right? And we can model this situation, this scenario now, with a linear function. Y equals m, actually, sorry, A and V. Okay, M and V. Boom, 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 boom. Okay. We can model this with y equals 8x plus 470. Now, usually we don't use x and y when we have a word problem. We're going to use letters that make sense. And we'll often use function notation as well. But we're not going to do that right now. So what is the output of this function? It's bricks, right? So I'm going to call it V, capital B for bricks. And instead of x, which is the number of minutes he takes, I'm going to use m. Or another common one is t for time, right? But I'm going to use t for time plus 470. M would also make sense, but I kind of want to avoid m because people get that confused with slope. M, slope. All right, and we can model this with a graph, right? And now in this particular case, because the start value is so high, I'm going to skip some, and we're going to have 460, 400, let's see, yeah, 470, 480, right? And we're going to create our graph from here, but realizing that there are some values that are skipped. Okay, but the start value, graph the start value, The start value is 470. And the rate of change is 8. So every minute we go over, we go up 8. Every minute we go up 8. 16. And every minute we go up 8. 16. And so that's 24. So 84, right? And so on and so forth. Okay? And so lo and behold, we get this nice linear graph. Okay? So hopefully that makes sense. Now, there's more to this lesson than just this. Okay? And in this particular case, by the way, would I want to connect the dots? Okay? Can he stack an uneven number of bricks? Can you stack 1.4 bricks? Not really. You can only stack whole bricks. So this is not really a continuous case, but it would be difficult to do it as single dots because you can stack 8 bricks per minute. So while the output is discrete, the input is continuous. Right, and we should have a x scale. So 0, 1, 2, 3, 4, 5, 6 minutes and bricks. Okay. The other kind of problem you're going to be dealing with is linear functions in the form ax plus by equals c, which is what we call standard form. So here's the kind of problem you're going to be doing there. You're going to be given a rate for 2 quantities, 2 items. So a common scenario for this is children's movie tickets or children's tickets and adult tickets. So let's say children cost $2 each and adults cost $7 each. And the total ticket sales from an event, total ticket sales was $400. Okay, total ticket sales. So in that case, we're going to let C be the number of children, and we're going to let A be the number of adults. Okay. Now I'm just going to set up a scenario here. Let's say that A was 15 and C was 10, right? There were 15 adults and 10 children. In that case, to figure out the total amount of money I would have made on ticket sales, I would take the number of adults, 15, and I would multiply by 2, or by 7, because each adult paid $7. And to get the amount I made from children's tickets, I would take the price of a children's ticket and multiply by the number of children, 10. Okay? And in this case, 7 times 15 is 70 and 35, 105. 2 times 10 is 20. 105 and 20 is 125. So there was $125 made off of ticket sales, but that's not what we made. So what we're going to do now here is we don't know what A is. We don't know what A is. And we don't know what C is. So let's replace that with A and C. Okay? So our formula becomes 7A plus 2C equals, now in this case, we're not making $125, we're making $400. 400. Okay? And that brings up a graph, right? So let's bring up Desmos. Okay. Right here. Right here. There's Desmos. Okay. And I'm going to graph. Now I'm not going to graph A and C. I'm going to graph 7x plus 2c because Desmos doesn't recognize A and C. 400 and 2x, 2y. Okay. 7x plus 2y equals 400. And you'll notice the graph doesn't show anything. Well, that's because we're dealing with very large numbers, and they don't go in standard, 0 to 10, right? So let's think of how we want to show the window here, right? So our x-axis, our amount of children's tickets, let's say we're going to let the number of children's tickets vary from 0 to 20. And let's say the y-axis, I want that to vary for the adult tickets from 0 to 20 as well, right? And that's not enough even then. So let's zoom out, zoom out. Ah, there we go, there we go. All right, and so we're getting a better picture here. We can fiddle with our settings here. So 200 seems to be the number of adult tickets here, and about 57.2, 57.143, so 57 child tickets. Okay, and so yeah, here's what this tells me. If I have 0 children and 200 adults, I'll make $400. If I have 0 adults and 57.143 children, I will make, actually I think that the X was the adults, wasn't it? X was the adults. 57.143 adults and 0 children, I'll make $400. And if I have 0 adults and 200 children, I'll make $400. And any combination therein. Now, of course, we can't have 57.143 adults because we don't divide adults like that into fractions. So, but any point along this line, if there's any whole number solutions, we will make $400, right? We will make $400. Now, I'm not seeing any whole number solutions here. And there may be some whole number solutions, there may not be. Let's say our goal here, was not that we're going to make $400, but we need to make at least $400. If we need to make at least $400, then this becomes greater than or equal to 400. The amount of money I need to make is greater than or equal to 400. Let me show you what Desmos does with that here. So I'm going to change the equal sign to a greater than or equal to. Now I typed greater than and then typed equals, and it put the equals for me. And what that tells me is any option that is in the shaded area now becomes a solution to this system. So for example, this point where my arrow is, which is at 40 and 100. If I had 40 adults and 100 children, I would make more than $400, right? And here's another solution down here. If I have 60 adults and 30 children, I will make more than $400, right? Okay, and so that's really it. There's a little bit about systems of equations, graphing them simultaneously to more than one, which is easy to do in Desmos.